here, we are in chemical reaction. This first part right here, all of these are active, so you should be able to see all of these. Okay, let me see if I can't do student view. No, student view limits me to in terms of what I can watch, and so let me go ahead and do this. If you can't get this view in Canvas, then let me know. But I think everything is okay. This first part right here is just a description of the experiment. It's basically the PDF of the entire experiment as found in your lab manual. Okay, so you could always do a preview by clicking on this little icon. Let me see if I can't blow this up further. Okay, let me change my screen, your screen view. That way you see this whole page here. I think this is it. Yeah. Okay, so yeah. So this right here is the page that you guys are watching. Again, this is the first part in, not here, in week, let's see, make sure that I'm in the right section. So for week, experiment number 7, this is it. This gives you the background information as well as the PowerPoint slide that I usually present in class. We'll take a look at this. This is the pre-lab quiz. It's like when you guys walk into class, you guys have a quiz. It's a very short multiple choice test. This right here is the pre-lab questions that is found in your lab manual. I put it as a quiz type. That way you guys, it's easier for us to grade. This is the video and data worksheet. This is where you upload your data sheet, and this is where you upload your post-lab answers. So again, let's go over here and let's take a look at the PowerPoint real quick. And let me try and orientate you in terms of this particular experiment. So where did it go? Here it is. Let me change screen real quick because it downloaded on my computer. Apologize for that. Actually, let me find it in my file, and then I'll just give you a quick preview of that PowerPoint and talk about specifics on it. So I believe this is it right here. Let me change the screen view so you guys can see this. Here it is. Okay. So what you guys are doing is you guys are going to be carrying out a reaction. You guys are going to make careful observations on that reaction. And hopefully you guys can get an appreciation for writing chemical reactions. So remember that when you balance the equation, that the atoms that you start with is equal to the atoms that you end up with. And so what you guys are going to be doing is you guys are going to be writing out the equations. Once you have the formula, don't change the formula. The only thing that you can do is change the coefficient. That is the value in front, and they represent how many of that chemical you have. This right here is the menu that you guys would use to indicate more information about the equation that you're writing. The plus tells you that they are co-reactants or co-products. The arrow tells you yields, or that's like an equal sign. You put in the different phases. And then if there's any symbol above the arrow, like a diamond, it means that heat was required. If there's a metal, that means that a catalyst was required. Okay, move on here. So again, when you balance these things, make sure you understand that once you have the chemical formula. Don't change the chemical formula. The only thing that you can do is change the coefficient. Okay. What are the evidence that the reaction's taking place? And you should write this in your observations when you are doing the lab. Maybe you see some smoke or some heat is generated by a flame. That's a gas formation. Maybe you see a precipitate that occurs when you mix two liquid together, and that precipitate is a solid, and it usually will settle to the bottom. Maybe there's a temperature change, in which case, since you guys aren't doing the experiment, we would show you a thermometer that indicates that the temperature either goes up or goes down. Or perhaps there's a new color that's formed, and you guys can make that observation. So these are the 4 signs that a chemical reaction has occurred. Okay. And you want to make sure that in your observations, you indicate what are the clues that a reaction has occurred. These are the different types of reactions. This is a combination reaction when 2 chemicals come together to form one. This is a decomposition reaction when 1 chemical breaks apart to many. This right here is a single displacement where 1 chemical replaces another chemical that is sort of ionic to form a new compound, and then that other second element is kicked out. Single displacement. You have 1 element displacing a single element. This is a double displacement where 2 chemicals, 2 elements switch partners. A form of double displacement is acid-base. Here, the hydrogen in the acid replaces the metal in the base, and what you get is water, H and OH, and then a salt, a metal and an anion. Here's an example. The hydrogen goes with this OH, the barium goes with that nitrate. Okay, and this is your combustion. A combustion is where you take some sort of fuel, you oxidize it in oxygen, and you burn it. You get a lot of heat, you get a lot of smoke, and you get carbon dioxide and water. So these are the different types of reaction, and I think your pre-lab question has to do with identifying whether you have a combination, decomposition, single displacement, double displacement. Again, these are just more examples. I'm just going to run through these real quickly. You guys can peruse it at your pace. Okay. Some of these reactions here are the reactions that you guys are going to be seeing in this lab. This is an acid-base reaction. Okay. This is the solubility rule. The solubility rule tells you which chemicals will always dissolve in water. Remember that when it says aqueous in the phase, that means that that chemical in water dissolves. It breaks up into its ions. When you see a chemical that is insoluble, what you will see in the phase in the reaction is a S. S, when you write a reaction, does not mean soluble, it means solid. Okay, so make sure that you understand that. Here, according to the solubility rules, sorry about that. Any chemical that has NO3, ClO4, or acetate are always soluble. There are no exceptions. So if you have lead nitrate, you have tin nitrate, you got gold nitrate, they're always soluble. There are no exceptions. Here, the halogens are soluble except if you have silver bromide, silver iodide. Then you don't get it dissolved in water, you get a precipitate. Okay, that's the exception. Sulfates are generally soluble except when you have calcium sulfate, barium sulfate, mercury sulfate, strontium sulfate, or lead sulfate. Group 1, if it contains any type of group 1 element, sodium, potassium, lithium, or ammonium, it's always soluble. There are no exceptions. Here are the insoluble substances: carbonates, chromates, phosphates, sulfides. They're generally insoluble except if your cation is an alkali, like sodium sulfide. That's soluble because this takes precedence over this. Okay, so you got to look at the rules and see which rules have a higher priority. these over here will always have a higher priority over these. So even though phosphates are insoluble, if you have lithium phosphate, because of this rule, then it's soluble. Okay, hydroxides are generally soluble, except if you have alkali or ammonium, and if you have these right here. Okay, so that's the solubility rule. Here is how you would write a double displacement reaction. Okay, and this is a good movie to show because, again, what you see here is aqueous. Aqueous simply means that this thing breaks up into its ions in water. This is aqueous. This breaks up into its ions in water. This is aqueous. It breaks up into its ions in water. Magnesium hydroxide is solid. How do I know it's solid? Look at the solubility rules. Right here, hydroxide, insoluble. These are the exceptions. You don't see magnesium in there. Okay, so magnesium is insoluble. That's basically what you see right here. So when you put this in water, this is what happens. Magnesium will go into solution, nitrates will go into solution, potassium will go into solution, hydroxide will go into solution. So that's your reactant. And then the reaction will be the potassium will go into the product, the nitrate will go into the product, but they're still aqueous, so they stay as ions. The next pair is magnesium and hydroxide, but these guys want to form a precipitate. So that's basically what happens. The potassium now is in the form of K in KNO3, nitrate is NO3 in KNO3 aqueous, and the magnesium hydroxide is your solid. So that basically is this right here is your complete ionic equation. The reason why it's called the complete ionic equation is because it shows all the chemicals in the reactant and the product that are ions. Anything that are not ions are indicated as a solid. So the top here is your molecular equation. The bottom here is your complete ionic equation. Okay. Now, if you look at these two in the reactant and the product, they're identical in formula and in quantity. These are called spectator ions. If we remove the spectator ions, and that's one set of spectator ions, and this is another set of spectator ions, then what we have left is the net ionic equation. You notice that we have magnesium here, but that's not magnesium ions in the product. We have magnesium here, but that's not magnesium ions in the product. So that's not a spectator. We have hydroxide here. That's not hydroxide ions in the product. So those chemicals, after you remove the spectators, represent your net ionic equation. It's the chemical species that is responsible for the product that forms. So that's your net ionic equation. So hopefully that visual makes it easier for you to understand the different types of the complete ionic equation. That's this right here. The reason why it's called a complete ionic equation is because it shows the formula of everything as they would be written. And you put AQ in the subscript to indicate that these things are soluble in water. You put S saying that it's a precipitate. The net ionic equation is going to be those chemicals that are in your water except for the precipitate, And then you have your complete ionic equation, and then you have your net ionic equation. Your net ionic equation is subtracting the spectators. Okay, so hopefully that makes sense. If you guys need to rewind this video or go to the PowerPoint and watch that movie again, hopefully it will be clear. So the last reaction that you have is a combustion reaction, and that's just heating something in the presence of oxygen and watching it burn. So this is basically the PowerPoint I would have presented in a lab so that it would prepare you for the experiment coming up. In chemical reactions, this is where you'd find the PowerPoint. Let's take a look at the pre-lab quiz. Pre-lab quiz is 10 minutes, 5 questions. Let's take a look at your pre-lab questions. And your pre-lab questions are found in your lab manual, but here it's given to you as a assignment, and it's also in the form of a multiple choice question. So let's do a preview real quick. And here you guys are going to, this is your pre-lab question. First of all, you're going to balance this equation. So look in your lab manual. It's going to be identical to what's in your lab manual. And then you want to put a coefficient in front of these. KClO3 goes to KCl and O2. You need to put a number. If you don't have a coefficient here, it's going to be marked wrong. If this is 1, put 1. Okay? Don't leave it blank. 1 generally is when you balance the equation and you don't put a coefficient in front of it. Doesn't mean it's 0. It means that there's one of them, but you need to indicate it here in this particular assessment. This is 6 points, this particular question. And then you have to tell me the reaction type. Use the letter A, B, C, or D to designate these types, just like your lab manual. Only type in the letter, don't put parentheses. Put either A or C or whatever this is. Don't put the parentheses. Canvas is very particular in the answer that you write. Otherwise, I'm going to have to go in there and overwrite this. So these are basically the questions that you would see in your lab manual. This right here, look for a YouTube video. Give me the URL of sodium reacting and potassium reacting with water, and then write your observation. Even though this is a small box, you can write as long as you want because the box will extend, okay? The box will extend. You're not limited to the size of this box. So write down your observation. The more detailed that observation, the better off you'll be when I grade these things. So the reaction of sodium with water and the reaction with potassium in water. Finally, these are true false. These are the same as in your lab manual. A soluble compound dissolves in water, true or false. And use only the letters T or F. Again, no parentheses. Hopefully that's clear. So let me get out of here, okay? And this whole thing, this is worth 6 points. This is worth 6 points. This is worth 3 points. So that's a total of 15 points for your pre-lab. Let me go get back out to modules. And let's take a look at your experiment. When you guys do this experiment, what you will see here is the following. You're going to watch the video because the video will give you an idea of the experiment that we have. So let's take a look at the video. And there's a lot of video here. Dr. Smith was able to find these videos and have it accessed. So here I've sort of put it in a table so that it's better organized. Scroll to the bottom to download the data sheet. So if you want to see what the data sheet looks like, you don't have your lab manual, click this. This is what you guys are going to be filling out as you watch these videos, okay? Again, the better your observations, the better your points will be for each one of these parts. A combination synthesis reaction, a decomposition. This is part A, part B, part C, part D, and part E. So these are based on the different types of reaction that you have. So if you look at the video, part A, they said it's a combination reaction. Well, that's what this is. The burning of magnesium in air, that's your combination, part A. So watch that video and then go in here and write your observations, okay? Make sure you are detailed. Part B, decomposition of the reaction. Let's go back into this table here. This is the decomposition reactions. There are two types: thermal decomposition of cobalt chloride hexahydrate and the decomposition of baking soda. In part B2, that's this, the splint burns for 9 seconds, the splint burns for 1 second. That's part of the observations that we want you to write down when you go in here. How long did the splint burn? Of course, you guys didn't do the experiment. We gave you that data, so make sure you write that in here. Part C, single displacement reaction, 1, 2, and 3. So let's go back to the video and let's take a look at that. There's 1, 2, and 3. The first is the hydrogen pop test. Second is copper in silver. And the third is zinc reacting with hydrochloric acid. If you click on these right here on this page, it'll open it up to the YouTube channel. Okay, you can fast forward this if you want or do what you need, but make sure that you write down your observations. It's very important that you do that. Okay, so let's stop here and let's go back to your data sheet. That's exactly what you're doing. You're writing your observations right here. And don't give me one word or one sentence observations. If you just give me a one word, oh, I see smoke, or you see smoke and heat, that's not good enough. You're not going to get a good a grade as if you use complete sentences and you are more detailed in your observations. And yes, I know it's difficult to be detailed because it's a video, but as a scientist, it's very important that you know how to make note of what you observe. D is a double displacement. There are 3 parts to D. Let's go to the video. There are 3 parts, 1, 2, and 3. The first is making silver iodide. Too bad you guys can't do this in the lab because this is a really cool experiment. What you do is you have chemicals, you put it in a test tube, you form a reaction, and then when the reaction is done, the inside wall of your test tube is going to be like a mirror plate. Okay, so that's a pretty cool experiment. The second one is the formation and dissolution of silver phosphate. The third one is iron chloride and ammonium hydroxide. So watch these videos, write your observations here. Okay, here you're going to have to write the complete molecular equation. The molecular equation, the complete ionic equation, and the net ionic equation. So that's why you need to review the PowerPoint that I presented. So that way you know what is going on. Notice that in this reaction, we tell you that the silver iodide is the solid precipitate. The second reaction is silver nitrate with sodium phosphate. Again, you want to write that reaction. The third reaction is iron chloride, ammonium hydroxide, forming iron hydroxide and ammonium chloride. You're going to be writing those equations. You might also, in terms of these, sorry, that's your observations. Write your observations first. Okay, I was jumping ahead, and then write the equations. And then in E, let's go to E. I was jumping ahead. Let's look at that equation. That's a titration lab with phenolphthalein. The first part, for 19 drops of sodium hydroxide was required. The second part, 42 drops of sodium hydroxide was required. So go to the observations, write that here in your observations. And then when you're done watching the video, or you can go back and rewind the video, you're going to have to write down the reactions for each one of those. Okay, you're going to have to write down the reactions for each one of those. Once you have these reactions, then you are done with the data set. You guys are going to be graded based on how correct your reactions are and how detailed your observations are. Okay, so please keep that in mind. Once you complete this, then you're going to upload your work, and you can do that. Let me minimize that on the next page. So this page right here is simply the data page. Here are more notes that I have up here, okay? But I write them down here as well. Let's go to the next page under assignments. And in the next page under assignments, again, that would be week 11, experiment number 7 here. We want to go to upload your data sheet. So when you click this, it'll give you a link. Here you can preview what the data sheet should look like. Okay, and that's basically the data sheet that you already saw. Let me go ahead and minimize that. Make sure if you have multiple pages, this is a short tutorial on how to take different pages and put it in a folder and then compress or zip that folder, and then you want to upload it here. So this is just the description of how to turn this in. And then what you want to do, of course, is go in here and then choose your file, and it should be one folder that's been zipped. Choose that file and then upload that file, okay? And it's got to be only one file that has been zipped. And then when I receive it in my end, I will unzip it and look at the different pages in that particular folder. So that's your data and worksheet. If you need to extend, if you need to be more detailed and put in a sheet of paper, then please do so, and make sure that you give instructions in the previous page to indicate that it's continued on a separate piece of paper. Let's move on and go to the post-lab section. Once you turn in your data sheet, then you're going to go in here and complete the post-lab section. So post-lab section is this, right here. If you want to preview what the post-lab questions are, it's in your lab manual, so you guys can see that. Okay, this is what it looks like. Okay, note the difference in length of time in the splint burning in part B2. Remember, one was 9, the other one was with 1. So try and explain why there's a difference. In part C, did your observation concerning the flame wooden is misspelled, splint agree with the reaction that you wrote for this section? Okay. Number 3, part E1 and E2, you start with equal amount of 0.1 molar acid. Look at the balance equation for these parts. Why did the sulfuric acid need more or less sodium hydroxide to turn the phenolphthalein pink than the nitric acid? So take a look at that and see if you can't answer these questions. Of course, you guys are going to write this in this worksheet, and then you're going to submit it. When you submit your work, it's got to be based from the worksheet in the lab. In my other section, they wrote it in a blank piece of paper, and then they wrote their answer there. That's not acceptable. You have to use the pages that is offered to you in the lab manual. Okay. So once you have completed the post-lab questions, click on this link to upload your file. And again, here it shows you how to, I don't know why that happened, but here it shows you how to, if you have multiple pages, to put it in a folder, to zip that particular folder, and then upload that particular zip folder. Okay, so that basically is what this experiment is about. You guys, of course, can take your time. You're not restricted to 3 hours. You're restricted till Friday midnight to complete this experiment. So